Hi Wildcats. I wanted to walk through a couple example problems for Unit 9, Focus Question 1, over work. So a long time ago when people weren't in quarantine, they used to go grocery shopping and they would push their carts down aisles. So this is a problem related to that. This shopper pushes their cart with a force of 35 newtons at an angle 25 degrees downward. So right when you push on a shopping cart, some of it's horizontal, but some of it's also down. And then we want to know how much work is done by the shopper on the cart as it moves along 50 meters. So I've drawn a picture. Here's my applied force of 35 newtons down 25 degrees, and then it goes 50 meters horizontally. So we want to know the force of the shopper, which they tell us is 35 newtons. We know the displacement is 50 meters, and we do have an angle here. So the only force causing the cart to move horizontally, these 50 meters, is the x component of this. So we could solve for that x component and just multiply it by distance, but we can also do that all in one shot with this equation. So we can start plugging in numbers here. We have 35 newtons times 50 meters times the cosine of 25 degrees, because we're solving for just the horizontal component. So the work done by the shopper is 1,586 newtons. We'll go 3 sig figs, so 1,590 newtons. So that's how much work is done over the 50 meters that they go down the aisle. So that's a simple one. One that's a little more complex is where we have an angle involved. So I have a 120 kilogram tractor moving up a 21 degree incline at a constant 1.5 meters per second. At the top of the hill, it has a displacement of 12 meters parallel to the incline. If the engine in the tractor applies a force of 1,272 newtons to move the tractor, and the coefficient of friction between the tractor and the ground is 0.48, what is the total work? Okay, so now we need total work. So that's going to mean we need net force done on the tractor. So I've got this all set up: mass, velocity, displacement, force, coefficient of friction, and they're asking for total work or net work. So we're going to need net force to get net work. Here's my picture: 21 degree incline. I've drawn all the forces. The applied force from the engine. There's some frictional force. We know that there's a force of gravity, and then we know that there's normal force, and it moves 12 meters up the hill. Again, this means resolving for a whole bunch of components. So just like we did in the last unit, I've redrawn my picture so that as few vectors as possible are at an angle. So now these are horizontal, applied force and friction force. Force normal is perpendicular to the surface, and the force of gravity is 21 degrees down, which means it has two components, a vertical and a horizontal component. So in order for me to get I'll need the net work is equal to the net force times displacement. I don't have to use cosine of angle, because since this is now horizontal, really the tractor is moving 12 meters this direction. So whatever the horizontal net force is, those are my forces. There is no angle involved, so I don't need to worry about it. Let's see, horizontal net force is going to be equal to the applied force plus, what else is horizontal? The force of kinetic friction plus, and now we need to remember this is a component, right? So force of gravity in the x direction. So I'm going to need to solve for all of those. Okay, so let's get to it. Force applied, we have, that is a check. Force of kinetic friction. So in order for me to get force of kinetic friction, I need force of kinetic friction is equal to the coefficient of kinetic friction times the normal force. So in order for me to get normal force, looking at my picture, is going to be equal and opposite to the horizontal or vertical component of gravity. So I need to solve for Fg So FGY is equal to the force of gravity times, this is adjacent, so cosine of the angle, which is going to be 21 degrees. So force of gravity is 120 kilograms times acceleration due to gravity, negative 9.81 meters per second squared, times cosine of the angle, which is 21 degrees. If I plug that in, I get the force of gravity's y component is equal to down 1,099 newtons. So that means normal force will be opposite, or normal force will be 1,099 newtons up, or positive. So now I can solve for the coefficient, or sorry, for the force of friction by taking the coefficient of friction, 0.48, and timesing it by normal force, which I know is 1,099 newtons. So the force of kinetic friction is equal to 5,027.5 newtons. So now I have that. Okay, so the last thing I need is the horizontal component of the force of gravity, since that's pulling it down as well. So I can solve for that by taking, in my picture, it's opposite, so that would be sine. So it would be equal to the force of gravity times the sine of the angle. So in this case, we know the force of gravity is 120 kilograms times negative 9.81 meters per second squared times sine of 21 degrees, and I get the force of gravity horizontal component to be negative 421.9 newtons. And I guess I should go back to force of friction, since it's to the left, is also a negative value. So that gives me, if I look at my picture, F net is all of those. I now have all those, so I can figure out F net. So F net is equal to the applied force plus the force of friction plus the horizontal component of gravity. So the applied force, they told us, is 1,272 newtons. So 1,272 newtons plus negative 527.5 newtons plus negative 421.9 newtons. So F net is equal to, I get around 322 newtons. And we know that work is equal to the work done is the total work done, net work, is equal to the net force times the displacement. In this case it's 12 meters, so 322 newtons times the displacement, which was 12 meters. So the work done, the total work done in this system is around 3,864 joules. So I hope that helps as you work through some of these problems. This one's more involved because we had to work through the components and everything. The first one is a little more straightforward, where we're just applying our force times the displacement by the angle. And I hope that helps. And as always, if you have questions, please let me know.